Hello from Edge Educational Academy. So in this video, we are going to start important 2 marks questions. So 2 marks question as well as bits from all the chapters. So we have completed pretty much 7 marks question and 4 marks questions from some chapters are pending. That will do, but 2 marks questions from all the chapters in a series. You are going to get all the videos like part wise how I have uploaded for all the 6 marks questions. So now as of today we are going to start with the first chapter, exercise 1.1, Euclid's division algorithm to find the HCF of two values 900 and 270. First bit. So we are going to solve the real 2 marks questions from real numbers. First exercise, finding HCF of two numbers, right, using Euclid's division algorithm. So what are the two numbers? 900 and 270. 900 and 270 are the two numbers we are going to find HCF of. So according to Euclid's, so first statement you write this: apply Euclid's division algorithm to 900 and 270. 900 and 270. What is Euclid's division algorithm? A is equal to BQ plus R. A is equal to BQ plus R. A is the dividend, B is the divisor, Q is the quotient, R is the remainder. This we discussed in case of polynomials as well. So we have to divide it here. Yeah, we have to divide 900 by 270 by 270. Now do we have remove this 00? So we are checking 90 in 27. Remove these two 00. So 90 in 27. In 27 table, 27 3s are 81. 27 3s are 81. So 270 3 is 810. 810. So we have this 0. This will become 90 minus 81 is 90. So this is the value of A. This is B. This is Q. Here we have R. Let us substitute it over here. So A is equal to BQ plus R, which is nothing but, what is A? 900. 900 is equal to B, which is 270 into Q, which is 3 plus R, 90. So we have to solve this till the value of R is 0. When the value of R is 0, whatsoever we have here in the place of divisor, that is the HCF. B is the HCF. A is equal to BQ plus R. In A is equal to BQ plus R, B is going to be our answer. But when the value of R is 0, is value of R 0 in this case? No. So we have to extend it even further. We have to apply Euclid's division algorithm to these two terms, B and R. So here R is not equal to 0. Is R equal to 0? No. So that's why here R is not equal to 0. Applying Euclid's division algorithm to what two numbers? 270 and 90. 270 and 90. Again 270 and 90. 270 divided by 90. 9 3s are 27. So 270. What is the value of A? A is 270. This is the value of A. This is B. This is Q. Here this is R. So A is equal to 270. 270 is equal to B. 90 into Q. 3 plus R. 0. So here R is equal to 0. So if R is equal to 0, what is the HCF? The value of B, which is 90. So HCF of 900 and 270 is 90. This way we have to find the HCF of two numbers. Another question which is there, 196 and 38,000 38,220. 38,220. So we have to apply Euclid's division algorithm to 38,220 and 196. We have to divide in such a way that the biggest number should be divided and the smallest number should be divisor. This is dividend, this is divisor. So I am doing the division here. Applying Euclid's division algorithm, what does Euclid's division algorithm say? A is equal to BQ plus R. Alright, in the rough work if we do, here it is 38220 divided by 196. 196. So 196 196 2's if we take, we are checking 3 digits here. 382 I am checking. So 196 into 2. 2 6 are 12, 2 9s are 18 plus 1 19. 2 1 is 2 plus 1 3. 392 it will become. If we multiply by 2 it will become 392, which is bigger or smaller? Bigger. So we have to take with 1. 196 1 is 196. If I subtract, this will become, this is 7, this is 12. 12 minus 6 is 6. This will become 2, this will become 17. 17 minus 9, 8. 17 minus 9 is 8. Now 2 minus 1 is 1. 186. So we have to get this 2 down. 1862. 1862 we have to check in 196. 196 is nearer to 200. So like that I am instead of going with multiplying with 1, 2, 3 and so on. So I am trying to narrow my search. 196 is nearer to 200. 200, 1 is 200, 2s are 400, 3s are 600, 4s are 800, 5s are 1000, 6s are 1200, 7s are 1400, 8s 16, 9s 1800. So I am trying to multiply that by 9. 196 into 9, very near to 1800, right? So that's why I am multiplying by 9. 9 6 are 54, 9 6 are 54, 9 9s are 81, 81 plus 5, 86, 9 1 is 9 plus 8, 17. We can take this by 9. So by 10 it will become 1960 if you multiply by 10, which is greater. So that's why by 9 what number I am getting? 1764. Right, after subtracting, 12 minus 4 is 8, this will become 7, this will become 15. 15 minus 6 is 9, and again 0. 980. 980 we have to check in 196. So now by 6 we have to get a 0 in the ending, right? So that's why multiply 6 by certain number. 6 1 is 6, 2s are 12, 3s are 18, 4s are 24, 5s are 30. So if we multiply 6 by 5, then we have this probability of getting 980. That's why instead of multiplying 4, 2, 3, 7, 8, that's why I am directly going for 5. 196 into 5. That might be true, might not be. However, I will have an idea. Nearer value. 5 6 are 30. 5 9s are 45 plus 3. 48. 5 1 is 5 plus 4. 9. 980 by what number? 5. If I multiply by 5, I got 980. After subtracting, this value is 0. So this is A, this is B, this is Q, this is R. Is R 0 here in this case? So we need not to multiply, we need not to do multiple divisions. In the one answer only we already got it. So what is the value of A here? 38220. A is equal to B into Q. What is B? 196. Don't get confused. 196 and 195 both are very nearer values. B into Q. Do not forget the order. B into Q. B is 196. 196 into Q. 195. A is equal to B into Q plus R. R is 0. So here R is equal to 0. So HCF of 38220 and 196 is 196 only. Clear? One more question is there. Will you be able to do that? Similar question, third bit. Third bit is there and some questions in the do this, try this are also there. So you give it a try, okay? Yeah. Next important questions for 2 marks is LCM and HCF. LCM and HCF either in 2 marks or in bits. One of the question is guaranteed here. See, LCM, for LCM remember this statement. LCM, if it is lowest, right? Lowest common multiple. If L is there, you have to write highest. Highest power of common factor and every other factor. To find LCM, remember this term, remember this statement. For LCM, what is it? Highest power of common factor and every other factor. We have for common factors, first of all, we have to take 2, 3, how many numbers are there? Those many numbers. We have to find the common first of all prime factors. We have to get the prime factors. Prime factors are nothing but 2, 3, 5, 7, 9, 11 that we discussed, right? So you have to check, find the prime factors of a given number. and amongst the prime factors we have to get the common factors. For the common factors we have to take highest power. I'll tell you, highest power of common factor. In case of common factor for any 2 or 3 numbers, you have to check what is the highest power that we have to take for common factor. The factors which are not common, for example, for a certain number, 3, 5 is the 3 and 5 are the factors, 3 and 7, 3 and 11 are there. 3 is a common factor. So 3 we have to take in all the numbers, but apart from common factor, whatsoever the other factors are there, that also we have to consider in case of LCM. In case of LCM, not just the common factor, but every other factor we have to consider. In case of HCF, only we have to take the common factor, and for common factor also we have to take the lowest power of the common factor. Just remember these two statements. We'll solve some questions, you'll get an idea about it. So we are trying to find the factors of 12, 15 and 21. 12 goes into 2 6 are 12, 2 3s are 6, 3 1 is 3. Right. Next 15. 3 5s are 5 3s, 5 1 is 5. Next 21. 21 goes in 3, 7s are 21, 7, 1 is 7. So 12. What are the factors of 12? 2 power 2 into 3. 2 power 2 into 3 or 3 power 1. Right. Next 15. 3 into 5. Next 21. 3 into 7. Chalo. Let us find the LCM here. What is LCM? Read the statement. LCM, highest power of first we have to take common factor. Is there a factor which is common in all the terms? Yes. For that common factor we have to take highest power, but in all the cases highest power is only 1. If nothing is there, highest power is 1. So we need not to worry about the highest power. So it is common factor is 3. Till here common factor story is completed, and every other factor apart from the factors which are common, we have to take all the other factors. For example, 3 is there, but 2 is also there. 3 is a common factor. 5 is also there for this. 3 is a common factor. 7 is also there. So apart from 3, apart from common factors, you have to consider all the other factors also. So what are all the other factors? 2 square into 5 into 7. Multiply all of this, you will get the value of LCM. Right. 2 square is 4. 4 5s are 20. 20 into 3, 60. 60 into 7, 6 7s are 42. 420. LCM. Clear? HCF. Multiplication you can already anyhow do, that's not a problem. If it is mistake also, get that corrected, not an issue. HCF. For HCF we have to get the lowest power of common factor. Only we have to check common factor in case of HCF. Which are not common, we need not to worry about them. What are the common ones? 3. For 3 also we have to take lowest power. Lowest power, 3 itself is the lowest because power is 1 in all the cases. That's why we will take only 3. 3 is the HCF. Lowest power of common factor, 3. Next, what is the second question? We will solve few more questions. Second one, second bit. 17, 23, 29. Questions नहीं देख रहे तुम लोग? 17, 23 and 29. If you know, these are prime numbers. This does not go in any table. 17 is nothing but 17, 1 is 17. 23 is nothing but 23, 1. 29, 1s. So 17 are, for prime factors of 17 are 17, 1. 23, 23, 1. 29, 29, 1. In order to find the value of LCM, we have to take common factor, highest power. Common factor is only 1. Its highest power is again 1 only. So 1 power 1, 1. Common LCM 1. We have to take 1 and every other factor, all the factors, 17, 23, 29. 23, 29 into 17. If you multiply all of these values, we will get LCM. Next, HCF. For HCF, we have to take only common factors. Common is 1. 1 is the HCF. Clear? What is the third bit? 8, 9, 25. 8. It goes in 2. 2 4s are 8. 2 2s are 4. 2 1 is 2. 9. 3 3s are 9. 3 1 is 3. 25. 5 5s are 25. 5 1 is 5. 8 can be written as 2 power 3. Prime factors of 8 is 2 power 3. 9. 3 square. 25. 5 square. Right. We have to take now LCM. In order to find the value of LCM, we have to check common factors first and every other. What is a common factor? Is common factor there? First of all, for common factor we have to take highest power. There is no common term only. Here we have only 2, here 3, only 5. No common term. Okay, this statement is completed. Highest power of common factor. If you have a common factor, then take it. If you do not have a common factor, leave it. Come to the next part. And every other factor. All the factors you have to take. Multiply all of these terms. Every other factor. What are the remaining factors? 2 cube into 3 square into 5 square. Right? 5 square is 25. 25 into 8. 25. These are basically this number. 25 into 8. 25 is 200. 25 rupees. If you take 4 times, it will become 100. If you take 8 times, it will become 200. 25 8s are 200. 200 into 9. 2 9s are 18. 1800. 1800 is the LCM. HCF. We have to take only for HCF lowest power of common factor. We have to only take a common factor. But what is a common factor? We do not have any common factor. 1. So answer is 1. So if we do not find any common factor, 1 will be the common factor of every number. So 1 is the HCF. Clear? Let us try to solve few more questions related to LCM and HCF. Then you will get an idea. Next, what is the next question? 72, 108. 72, yes, this is the nice question. You will understand here now. 72 goes in 2, 2 3s are 6, 2 6s are 12, 2 1 is 2, 2 8s are 16, 2 9s are 18, 3 3s are 9, 3 1 is 3. 108. Again it goes in 2, 2 5s are 10, 2 4s are 8, 2 2s are 4, 2 7s are 14, 3 9s are 27, 3 3s are 9, 3 1 is 3. So 72 can be written as 2 square 3 cube. Sorry, 2 cube 3 square. 2 cube into 3 square. 108 can be written as 2 square into 3 cube. Very good. Yes. LCM. For LCM, what do we have to do? For common factors, we have to take highest power. For common factors, you have to take. What are the common factors? 2 is there. 2 is a common factor. What is the highest power? 2 cube or 2 square? 2 cube. For 2, we have to take 2 cube. And what is the next common factor? 3 is also common. 3 square or 3 cube? 3 cube. For common factors, we have considered this. Now, every other factor. Is there any other factor apart from common? No. In this question, there was nothing common. That's why we considered all the other factors. In this question, only common, no other factor. Clear? 2 square into 3 cube. If you multiply these two numbers, you will get the value of LCM. Multiplication you can do next. HCF. HCF is the, what is HCF? Lowest power of common factor. 2 cube, 2 square. 2 square. Lowest power we have to take, which is 2 square into 3 square, 3 cube. 3 square. 2 square is 4, 3 square is 9, 9 4s are 36. 36 is the HCF. Clear? Understood? For LCM, we have to take highest power of common factor and every other factor. In case of LCM, we have to take that. In case of HCF, only common factor, that too their lowest power. Next. What is the next bit? 306, 657. 306 and 657. 306. It goes in 2 table. 2 1 is 2, 2 5s are 10, 2 3s are 6. 153. It doesn't go in 2 table. You have to check in 3. 3 5s are 15, 3 1 is 3. 51, it goes in 3. How do we identify whether a number goes in 3? Add all the digits and check. Like 5 plus 1, 6, 6 plus 3, 9. Is 9 there in 3? Yes, so 153 will also be there. 51, 5 plus 1, 6. Is 6 there in 3? Yes, so 51 will also be there. 3, 1 is 3, 2 carry, 3 7s are 21. 17 is a prime number. It doesn't go in any table. Leave it there. Next. 5 plus 6, 11. 11 plus 7, 18. Is 18 there in 3? Yes, so this number will also be there. 3 2s are 6, 3 1 is 3, 3 9s are 27. 9 plus 1, 10, 10 plus 2, 12. 12 is there in 3, so this number will also be there. 3 7s are 21, 3 3s are 9. 73 is a prime number, it does not go in any number. 73, you leave it there. Right. Sir, how do we identify, how can we get to know that whether a number is a prime or not? Practice it more. You will get to know. There is no other option to that. Now, 36. 306. How can this be written? 2 into 3 square into 17. 657. 3 square into 73. Chalo. LCM. What is a common factor? 3 square. 3 square and 3 cube it was there, then we would consider the highest power, but in common factor both of them 3 square only, so we will consider 3 square. Highest common factor ka highest power and every other factor. Apart from 3 square, 2, 17, 73 into 2 into 17 into 73. If you multiply these values, you will get LCM. HCF. Common factor only we have to take that to its lowest power. In both the cases, the power is same, so which is 3 square. 3 square is nothing but 9. That is a HCF. Clear? Few more questions I will give at the end of the session. So this is how we find LCM and HCF. Next, check whether 6 power n can end with digit 0. Six power n can end with digit 0. Is it possible? 6 power n. Similar kind of question will be given. See, 6 power n can end with digit 0. In most of the cases, you will directly what you do, you will put the value of n as 1, 2, 3, 4. If you take 6, 6 power 1 is 6, 6 power 2, 36, 6 power 3, 216. So it will end with 6 but not with 0. That is not the actual way. For last two question number 6 is there, no? Question number 6 is there. 6 power 100 is asked. What is the digit in the end place? What is the unit digit if we put 6 power 100? In that case, for that question, you can try this method. So understand here. Can it end with digit 0? So only those numbers whose prime factor is in the form of 2 and 5. Whose prime factor is in the form of 2 and 5 can have digit 0 at its end. Prime factors of 6. Prime factors of 6 goes in 2, 2 3s, 3 1. Prime factors of 6 are 2 and 3. So can we have 0 in the unit digit? No. For example, 10 I am taking. Prime factors of 10. 2 5s are 10, 5 1 is 5. Prime factor of 10 is 2 into 5. 2 into 5 power you take anything. 2 into 5 is 10. 10 power anything. 10 power 10. Whatever number it is, but it will end with 0. So basically what we are trying to understand over here, so this base number is there, no? The prime factors of this base number should have 2 and 5. If the prime factors of number which is there in the base has the 2 and 5, then that particular number will end with a digit 0. If the prime factors is not 2 and 5, instead it is some other thing like 3, 6, 2 is there but 3 is not there, 3 is there but 5 is there but 2 is not there. In that case also it won't end. Like 15, for example, 15 power n. Will it end? All you have to do is find the prime factors of 15. Prime factors of 15. 15 goes in 3 5s, 5 1. So we should get a 2 and 5. 2 and 5 is the key. 5 is there but 3 is also there instead of 2. That's why it will not end with digit 0. For this also, for this case 6, 2 is there but 5 is not there, instead 3 is there. So it will also not end with a digit 0. So what do you write as answer? So prime factors of 6 is not in the form of 2 and 5. That's why it will not end with digit 0. That is what you have to write as an answer. Clear? Understood the concept? It is not just about putting 1, 2, 3 in the power, because instead of 6 it might ask any other number. So no matter what number it asked, all you have to do is find the prime factors of that number. And if the prime factors of that number is in the form of 2 and 5, then we can say that it will end with digit 0. If the prime factor is not in the form of 2 and 5, it will not end with digit 0. Now this is the question. Another, product of any two numbers is equal to product of their LCM and HCF. In this question, understand, product of any two numbers, if any two numbers are there, if any two numbers are given, so product of those two numbers is equal to product of their LCM and HCF. For example, A and B are 2 digit. A is a certain number, B is certain number. LCM of A, product of LCM and HCF. So if two numbers are there, for example, any two numbers if we take, 4 information is there. 4 information, 2 numbers A, B and their product of their LCM and HCF. LCM of AB, HCF of AB. So this is one number, this is one number, this is the first, this is the third one, this is the fourth one. Amongst these four, any three will be given. Among the four digits, among the four values, any three will be given. Like two numbers will be given and their LCM will be given. We have to find the HCF. Two numbers will be given and HCF will be given. We have to find the LCM. LCM and HCF of two numbers will be given and one of the number will be given. We have to find other number. Any which ways we have to utilize this formula. Correct? Understood this? Right. Let me find a question.